Alright, welcome to video 2. In this video, I'm going to show you how to solve for the angle given area, side. So this is the given the area problems and solutions series, video 2, and I'm going to show you how to do it using the area formula of the triangle and some trigonometry. And I'm going to show you how to put trig functions, solve trig functions in Excel. And let's zoom out real quick. I'll get you the video series in case you're just jumping in the middle. You'll see there's plenty. I'm going to try to title them given the area, problems and solutions. So if you do a search, you'll be able to find out how to do any of these area problems. Let's go to video 2. So here we go. We're going to have to solve that, and to do that we're going to have to turn this into a, so all this trig stuff's about right triangles. We're going to create a right triangle, and we have enough information to do that because we know the sine of angle A is h over 36. So if we have enough information to solve for h, we can solve it, and we do. We have the area formula is 1/2 the base times the height. So 1/2 the base, we have that. The height is missing, and the area we have. So all that's missing is h. Solve for h. And there's how you do that. Just 1/2 base times the height. Solve for h, you get 18. Now we have interesting. What the heck happened there? So now that we've solved for 18, we have the two sides of a right triangle, which means we can solve for a. So we have the opposite side over adjacent side is the sine of a. We have the sine of a equals 18 over a is 36. Or we could say the sine of a equals 0.5, like doing the division. And then we know the arc sine of 0.5 is 30 degrees. So in this program, this is DesignCAD 3D Max. I'll show you a cool feature this thing can do, and then I'll get to the Excel. Open up tool, open up the calculator. We have arc sine 18 divided by 36. That extra step in there is not necessary. Then I hit compute and I'll get the 30 degrees. So a nice feature about this DesignCAD. If I'm drawing a line and I hit point polar, I can hit the distance of 36 like we have here. And I don't know what the angle is, but I can put in, no, I do it now, but if I didn't, I could say arc sine of 18 divided by 36. And then I can hit OK, and I'll have a line that's 36 long at 30 degrees. No, it's not. Oh. V point polar 36 arc sine open parenthesis 18 divided by 36. I think I must have had a typo in there. And like I said, 36, 30 degrees at 36 long at 36. Try to do that in AutoCAD. I don't know how. I digress. So that's how you put it in this program. Let's look at how we do this in AutoCAD, in Excel. I'm going to copy this and paste it into, and this is another nice feature it does. If you want to put it in, if you're working with Excel, you can just go drop the image right into Excel. Very nice, huh? And then let's do, I'm going to show you how that works. I did it here, but I want to show you here. I had a video fail, but likewise. So let's give it the area formula: 1/2 times base times height equals 1 area, right? That's our area formula. So we type in what we have: 1/2 times 20 times h equals 180. The reason why I'm doing it this way is this is how I solve them, so I can see what I'm doing. Just type it down. Now I know that I need to multiply by 2 and divide by 20 to gauge by itself. So I have 1h equals 180 times 2 divided by 20. And that I can copy right now, copy that, and I can paste it right there. And I'll get my 18, right? So I could use that 18. Let's say the given is 36. We have the diagonal, we have the base is 20, and we have the area. What I would do is I would make these red. Let's go to the text color, make them red. And those are the ones that I can modify. So then everything else in here I would turn into like I would call that height, enter. And then let's say the angle, let's call that angle A. We'd put in the formula that we said was, so we want sine. So if we look here, if you want the sine of 30, you got to type it in one way. If you want the arc sine, you got to type it in that way. So degrees, arc sine, 18 divided by 36. So we would type in equals degrees, A sine, and then I would go 18 divided by 36, those parentheses twice, and then we would have our 30 degrees. So you can see how this would be useful. You just start, and then if this triangle changed, you just change the inputs, and you know, that's how you would run that's how you do the degrees. The sine, I didn't show you how to do the sine, but if you wanted the sine of 30 degrees, let's say you would type in equals sine, open parenthesis radians, open parentheses again, and then you type in 30 right here, close, and it'll return if it wasn't in text. Let me put it right there. And then take this, turn the format to cell to number. And then I can get the equals. So I can just copy and paste that. And I'll get there at 0.5. And the cool thing about this is you can set that up to 15 decimal places. So as you're doing all your calculations, your final answer, you only want it in 2 decimal places, but you can have everything that leads up to it to the 15 decimal places. Even if it's only showing 2 here, it's carrying it out to 15 decimal places, or maybe 12. But that's you know, like a trillionth of a degree, that decimal here. Maybe later, yeah, I'll do it later. I'll show you. That's about it for video 2. If that interests you and you think it's going to work, let me know if you see something on one of those videos that you want me to do first, because it might take a few weeks. At this rate, it could take a month, but I'm not making the drawings anymore, so I'm going to just create the videos from the drawings, so that should be pretty easy. If you have one that's looking like you don't know how to do it specifically, leave a message and I'll try to hit. I can do it at a turn, hit it first. All right, next one. Otherwise, I'll see you on video 3.